Let g be the function given by g of x is equal to the integral from 0 to x of sine of t squared dt for x values between -1 and 3, including our endpoints. On which of the following intervals is g concave down? Well, by the fundamental theorem of calculus part 1, since we know that g of x is equal to the integral of sine of t squared dt, if we were to take the derivative, or g prime of x, it would be equal to the integrand that we have here in terms of x, so sine of x squared. All right, and now if we remember from derivatives, concavity is found utilizing the second derivative. So we can actually find the second derivative. The derivative of sine is cosine, and then we still have our angle x squared. But then because our angle is more than just the variable x, we need to apply the chain rule here and find the derivative of x squared, which is 2x. If we simplify this, it will become 2x times the cosine of x squared. And now to determine the points of inflection, or the starting and ending points of concavity, we need to set our second derivative equal to 0 and solve for x. Well, the first one's easy. X is equal to 0 because 2 times x, that could be equal to 0. So if we solve that for x, we would get 0. The second part is, where is the cosine of any angle, say theta, equal to 0? Well, that happens at pi over 2, 3 pi over 2, 5 pi over 2, etc. And we also usually have plus or minus when we're talking about the cosine function. So let's then set x squared equal to these values and solve for x to see if they fall within our domain. So we have x squared is equal to pi over 2. And if we square root both sides, we will get, so square root of pi over 2. It's important to make sure that the division by 2 is still a part of the radicand. And we get 1 and about 253 thousandths. We have 1 and 253 thousandths as 1. Now, because we took the square root of both sides, we usually have to consider plus and minus. However, because our domain is only from -1 to +3, the negative of this would not fall within our domain. So the positive value is enough. Okay, now let's also set this equal to 3 pi over 2. And then if we square root both sides, we will get that the x value is 3 pi divided by 2, and we're still in that integrand, which is good. Now we can get out of the radical, and that will equal about 2 and 171 thousandths, because we're rounding to the nearest thousandth here. 2, 171. Okay, let's also check out the x squared being equal to 5 pi over 2 and square rooting that to see if that falls within our domain. And here's what we would have. Let's evaluate it. Okay, that does still fall within. So we have that x is about 2 and 802 thousandths. Okay, and if we did 7 pi over 2, just to see where it falls, 7 pi over 2, that one's definitely out of our domain, so we don't have to worry about that one. All right, so we're going to create our sign chart with the values that we have. So in order to make some room, I'm going to get rid of the equations that were set up. Okay, so on our number line, we have from -1, we do have 0 as a key point, and then the next one is 1 and 253 thousandths, then 2 and 171 thousandths, then 2 and 802 thousandths, and then it ends at 3. Okay, so let's select values in between here that will help us test this out. So between -1 and 0, we could do -1/2. And this time, because we have a little bit more, we have the 2x cosine of x squared, we're going to substitute it directly into our expression. So we have 2 times -1/2 times the cosine of -1/2 squared. And actually, we need to make sure that we put a parenthesis around the -1/2 there so that it evaluates it correctly. And then we'll evaluate it and we get a negative value here. So it's negative here, that means it's concave down. And now let's pick a number in between 0 and 1 and 253 thousandths. So let's pick 1. So we'll have 2 times 1. We'll have 2 times the cosine of 1 squared, which is 1. So we have just 2 times the cosine of 1. And when we evaluate that, we get a positive value. So we have positive for this one. And now if we evaluate in between 1 and 253 thousandths and 2 and 171 thousandths, we could pick 1.5 or 2. I think 2 is an easier value. We would have 2 times 2, which is 4. 4 times the cosine of 4. So 4 times the cosine of 4. When we evaluate this, we end up getting a negative value. So we have concave down here for this value. Okay, now we've got to pick something between 2 and 171 thousandths and 2 and 802 thousandths. Let's pick, say, 2.5. That's right in between there. So 2 times 2.5 will be 5. So we have 5 times the cosine of 2.5 squared. And when we evaluate that, we have a positive value. So we have concave up right here. And then in between 2 and 802 thousandths and 3, we could pick 2 and 9/10. And 2 times 2 and 9/10 will be 5 and 8/10. And then we have the cosine of 2.9 squared. Close the parenthesis around that, and we get a negative value. So that means we have concave down again. Okay, so we have it concave down between -1 and 0. That one works. Again, between between 1 and 253 thousandths and 2 and 171 thousandths. That's Roman numeral 3. And then we also have it again in this last one in between 2 and 802,003. So we're looking for an answer choice that's Roman numeral 1, 3, and 5. And I accidentally checked off the wrong one. It's down here, this one. So 1, 3, and 5 is answer choice C.